This is the way of describing a scientific result, because the EDS is not enough informative to tell you the exact composition, because there are chances of other contribution from other areas. But if the sample is completely crystalline, then that worry is a little bit not significant. If it is a single phase and there is no glass or other phase, but in practice, usually when you deal with samples, some ions are volatile, right? Some ions are volatile, and on the surface, the composition will be different in comparison to the bulk, because in the bulk, the volatile ion cannot escape. So the surface composition is usually deficient in the volatile cation. For example, you have barium, zinc, tantalate. It is an oxide composition commonly used in electroceramics. Zinc is volatile. So if you measure the composition on the surface of that material and then you go to the bulk, the surface will be deficient in zinc, because it is volatile, and at high temperatures when you treat the material, although your composition was exactly stoichiometric, but because of the volatility of that particular element, the material will be deficient in zinc at on the surface and stoichiometric in the bulk of the material. Now, if the material is something like this, you have a polycrystalline material like this, and then another crystal starts here, right? Now, this triple junction is usually different than the bulk of the sample. This triple junction here, usually the composition is slightly different. Are some materials easily come out towards surface in comparison to the other? Because when you grind the material, you grind the tops, and this triple junction, if there is a slight void or a little space, then it is representing some sort of surface, right? If you combine these things, for example, I combine these things here and I grind this sample, right? These are three grains joining together. So this middle is a void, it is a free space there. And the composition of that free space might be slightly different than the grains. So the triple junction, it is also a huge research topic, and people write books upon these and write papers upon these, that what is the impact of triple junction in that particular material. So again, the composition can be slightly different. So by fully crystalline material, if you are doing microscopy, I will advise you to look into this grain composition, this grain composition, this grain, if you are using scanning electron microscope, or if you are using TEM, then you are talking of crystals. So don't rely on a single crystal. Take spectra from as many crystals as you can. That will give you a better statistics. Because standard researchers, when you submit an article for publication, their first question is, how much accuracy is there? How much accurate your data is? Is it plus minus 0.1? Is it plus minus 0.001? Is it plus minus 2? Is it plus minus 5? Because it is a big variation. When plus minus 5 you are talking of, then you have a free space of 10 degrees or 10%. right? So it depends upon the resolution as well as the statistics of your result, that how much correct the information. So the more information you collect, the more accuracy you will achieve. Similarly, a single sample is usually not enough to decide the nature of a specific material. That if I cut a piece from here, there is a lot of chance that this will be a different material than the bulk. So an intelligent and smart researcher will be the one who select a sample here from the edge, from the middle, and different areas. And when you study multiple samples, then you get more reliable result, and you will get more and more confident about what you are telling people or you are publishing. But if you stand in the defense of your PhD or MPhil defense, you are presenting your result and you are talking of a single sample, and I ask you that can you believe that a piece from this wall, which was 3 millimeter or 1 centimeter square, for example, is it reliable to rely on this sample for this whole room? There are many other things as well. So your sample selection must be representative of what sort of information you are giving. If you look into the mountains, the mines, there are veins and what you can call them, in Pashto people say, raguna, right? Raguna means arteries and veins which run through miles and miles of a specific material. And you took a piece of stone from the mine, from the mountain, and you said this mountain comprised this material. For example, gold. So the whole mountain is not made of gold. You will have to specify that I got 3 or 4 samples from different regions of that particular artery or vein, and the microscope told me this. You are not saying this. The machine is telling you this, and you give the specification of the machine, the experimental conditions of the machine, everything is given because the information, the accuracy, the reliability, the authenticity of the information depends upon the information you give. For example, if I say something else and you say something else, then the researcher, the next student, the researcher will look for the techniques me and you used. If you used a different technique and I used a different technique, you used one set of parameters, I used another set of parameters. If you are using a microscope at 100 kV and its beam cannot transmit properly through the sample, and another person use a 300 kV electron microscope, he see more things than you saw in that sample, because the 100 kV microscope couldn't transmit through multiple regions of the sample, but the 300 kV beam passed through many regions, and that give you 3 times or 4 times more information. In other words, a number of crystals which could be signatures of a particular phase, you missed them and the other person saw them. So if you don't know that he used 300 kV and I used 100 kV, then you can't explain that result. You can't defend that result. Right? So full information should be given. The best student, the best thesis globally are considered the ones which are picked by a student and he can repeat your PhD. You should write your thesis, your results, and every bit of your technical writing in such an easy, comprehensive, and self-explanatory way that if after 100 years a student picks up the thesis you have written and he can repeat the experiment, that is the best thesis. But the comprehensiveness is also a must. There should not be so unnecessary details which bores others to read. So that it must be comprehensive, it must be written in an analytical way, in a logical way, and a sequential progression must be there. When you say that I went to Mardan, I bought a book from Kisakwani Bazaar, and I ate food in that hotel. So it has no interconnection. And after each sentence, you are saying something else. The sequential progression must not be lost. This is very, very important. If you are a journalist, if you are a writer, author, you are a student, you are writing an answer to a question in your paper. And if that continuity is lost, then the reader is not interested in your reading. So the best writer is the one who can take with him the readers. And he never loses the readers from him. So sequential progression is also equally important. But comprehensiveness is usually stressed upon by experienced professors that whatever you write must be the most comprehensive as you can. But at the same time, never ignore the information which is required and you are not giving that, right? So when all these aspects gather together, that make you a best researcher. So specimen preparation method you choose depends on both the type of the material and the required information. So I was explaining the required information, that what sort of information. If you are needing just an image, then again a good sample will give you a better image. But if you are interested in diffraction pattern, then you need enough thin areas so that you can get good diffraction patterns from the sample. I told you that if you focus the beam here and the crystal is thick, you will not be able to have a transmitted beam. You will have to come to the edge. On the edge, there is a possibility that you have a transmitted beam as well as the diffracted beam, and some sort of diffraction pattern will be formed there. But if the sample is really thin, then anywhere in the crystal you can focus the beam and you can get the diffraction pattern, right? So the sample preparation is so important. It depends on time constraints, availability of equipment, your skill, and the material itself, right? How much skilled you are and what is available with you. When you go to the electron microscopy labs and you come for sample preparation, there may be one ion beam thinner and there will be 200 students in the department, right? All of them may not be doing electron microscopy, but most of them may be doing. So your time schedule, and again, you can't run a machine for a week or per month. You will get a day, half a day. In our times, the booking times was, for example, from morning to evening. Now, when smartness came, people got more experience. They have slots on the booking sheets for 2 hours. So you book for 3 consecutive sessions. So you can use the machine for 6 hours. But if your sample needs 1 month, this means you are never able to prepare a sample because you can never get a whole month in a standard lab, right? So this is why it is very, very important that what is available equipment and how much time constraints are there. Your prepared sample must be electron transparent, as I have told you, and representative of the sample you want to study. If it is not representative of the sample you study, then again it is useless. You must satisfy the audience, the reviewer, the evaluator of your results, of your thesis, of your publication manuscript, that you have adopted the standard way, the most standard way. And for that standard way, it is not that you say and it is believed. No. The standard way in research is that you refer to some earlier research works that they have done this. That is why I did this. The previous researcher from the literature, you know, that plane, they have adopted this method. They have done this, and that is why I am doing this. If the sample preparation is there, then go to the books and find out what sort of sample preparation is needed for that particular, and how you select the sample, which one will be the most reliable way of selecting a sample. For example, this wall you are studying and you cut a piece from the edge, it is not representative of it. The best thing will be that you cut a piece from the edge, a piece from the middle, a piece from the surface, a piece from the bulk, and then you look into it, and then you will be able to tell something about the composition of the wall. So always keep in mind that the first question people ask you is about your sample selection. Is it standard or not? If it is not standard, then your whole work is in a way useless. And people can reject your thesis on that basis. If your sampling is not correct from the very start, then how can you defend your thesis? Right? So, sample preparation is a skill and time consuming. There are always shortcuts, but cannot substitute for hard work and careful experimentation. Shortcut is always a wrong cut. So if you are doing something, then do it from the core of your heart and work hard so that you lead the field. If you adopt shortcuts, then many flaws will appear in your work and you can never become a leader in the field. But if you follow the proper way, the proper method, one thing, the old teachers who were teachers of our elders, they are still remembered as very excellent teachers. They are very well respected. They are honored. Why? Because they were never teaching you to adopt shortcuts. My father told me that I was in year 5. So it would be about 1947 or 46, even before that, right? And he told me that our teacher came to the classroom and asked us that, did you buy geometry boxes? And people said, yes, we have bought it. And when my turn came, I told the teacher that, yes, I have bought it, but So the teacher told me that, okay, when the school is off, your first duty will be to bring that geometry box to my house and show me that you have bought it. So he said, I was running very quickly and came and took the geometry box and went to his home. He, in a proper way, washed his hand, then had his lunch, and again washed his hand and dried them, and then told me, okay, come on, show me the geometry box. My father told me that when I showed him the geometry box, he picked all the tools one by one. That this is protector, yes, it is present, and he put it there. This is divider, yes, it is, and picked it here. And my father told me, he was about 80 when he was telling me that in the last 70 years, I couldn't forget that lesson. That is the perfection, that whatever you do it with immense sincerity and honesty. And it will become, what you say, a sacred asset for you and your life. When today I am remembering that teacher in positive words, he can never die. He will be always alive in the minds of his students and their students and their students. And what he has spread, taught to the people, it will remain in this world. And he will be praised, right? That teacher, I remember him, he died in 1976. But still I remember him. And he was my father's teacher, not my teacher. So this is the thing, that whatever you do with utmost honesty and sincerity, it becomes your asset as well as your students and follower asset as well. So never go for shortcuts and find the easier way. It is not bad that if you find the easier way, but that should not be missing or disinforming people about what you do.